Hello AFDA students, we are going to start our unit on probability, and we're going to start with some definitions. So our words are in the bold. The first word is event. So an event is the outcome of an experiment. For example, if you roll a die, the event could be rolling a 3. So you need to fill in now. If you toss a coin, the event could be, pause the video and try to answer it. Okay, so you could have written heads or tails here. I'm going to put tails. But you could also put heads, it doesn't really matter. Alright, probability. Probability is the chance that an event will happen. The probability could be from 0% to 100%. Probability is the number of successful outcomes over the total number of outcomes. Here's your example. The probability of rolling a 3 is 1/6 because there is one side of the die with a 3 and there are 6 sides altogether. And this is the way you would write this. The probability of getting a 3 is 1/6. Now you're going to do the example if you toss a coin, the probability of getting a heads. So you need to pause the video and give that a try. Okay. So on a coin, there's one side with a head, so there's one way to be successful, and there are 2 possibilities altogether, heads or tails. So the probability you get heads when you flip a coin is 1/2. Sample space is next. Sample space is a list of all possible outcomes. So if you roll a die, the sample space is 1, 2, 3, 4, 5, 6. Those are the sides on the die. Remember, the die is this cube, and if you have 2 of them, they're called dice. And let's go back to the coin here. Obviously this side is heads, and for some reason this side, even though there's no tail, is called tails. So now you need to look at the next example. If you toss a coin 2 times, what would the sample space look like? So remember, you're going to have, for example, one of the events be that you get tails and then tails. And you need to now pause the video and write out the rest of the sample space. So you could get tails, tails, or you could get tails, heads, or you could get heads, tails, or you could get heads, heads. So the sample space lists all the possibilities. Alright, so now we're going to talk about different types of events. So remember, an event is just the outcome of the experiment. 2 events are mutually exclusive if they cannot occur at the same time. So for example, when you roll a die, you can't roll both a 2 and a 3 in the same roll. So rolling 2 and rolling 3 are mutually exclusive events. So pause the video and write an example for mutually exclusive events for when you toss a coin. Okay, so when you toss a coin, heads and tails are mutually exclusive because you cannot get both of them. Okay. Independent events. 2 events are independent if the result of one event does not affect the probability of the other event. So for example, if I roll a die twice, it doesn't matter what I roll in my first turn, I'll still have a 1 in 6 chance of rolling a 3 on my second turn. So I want you to think about independent events and relate that to tossing a coin. If I toss a coin and I get tails on the first turn, I still have, pause the video and fill that out. Okay. So I still have a 1 in 2 chance of getting, and you can say either, it doesn't matter, tails on the second term. Okay, so if events are not independent, then they're dependent. One depends on the other. Two events are dependent if the result of one event does affect the probability of the other event. So in this case, our example is a drawer with 3 blue socks and 5 white socks. If I choose a sock at random, the probability that I'm going to choose blue is 3 out of 8, because there are 3 blue socks out of 8 socks altogether. After I take that sock out, there are only 2 blue socks and 5 white socks in the drawer. If I choose randomly again, the probability of blue is 2 out of 7. So, choosing socks are dependent events. Because once I take one sock out of the drawer, that changes the numbers for the second sock. The complement of an event is the outcome that is not the event. For example, the complement of rolling a 2 is not rolling a 2. So pause the video and write down the complement of tossing a coin and getting heads. Okay, you should have written the complement of tossing a coin and getting heads is tossing a coin and getting tails. Or you could say not getting heads. They're both fine. The difference between mutually exclusive and complementary. So mutually exclusive and complementary sometimes might overlap. But here's the difference. Rolling 2 and rolling 3 are mutually exclusive, but are not complementary because they don't describe all possible events. Rolling 2 and not rolling 2 are complementary and mutually exclusive, both. So we're going to use these definitions now on the other side. You should pause the video and you should try the next side of the page. Okay. So on this side it says, given the following events, identify each one as dependent, independent, or mutually exclusive. If they are mutually exclusive, say whether or not they are complementary. So, National Football Conference team wins a Super Bowl, and an American Football Conference team wins a Super Bowl. So, a team can only be in one conference or the other. So we would say that these are mutually exclusive events, and since those are the only 2 conferences, we would also say that they're complementary. Number 2, the Washington Redskins win the Super Bowl and the Washington Wizards win the National Basketball Association Championship. So both of these things could happen, so they are not mutually exclusive, and the teams have very little to do with each other, so we would say that these are independent events. The Washington Redskins win the Super Bowl, and Washington, D.C. has a parade. So D.C. has plenty of parades without the Redskins winning the Super Bowl. However, if they win the Super Bowl, that will increase the odds that Washington, D.C. will have a parade. So the parade might be dependent on the win. So we would say these are dependent events. Alright, the first 2 numbers of your Pick 3 lottery ticket match the winning numbers, and the third number does not match. So when they choose the numbers for the lottery, they randomly choose the first one, they randomly choose the next one, and they randomly choose the next one. So assuming that, let's see, that each time they choose them, they're still choosing 0 to 9. 0 to 9, 0 to 9, 0 to 9. If that's the case, then they would be independent events. So Gus takes the bus to school and he receives a speeding ticket on his way to school. So if he takes the bus, then he cannot receive a speeding ticket because he didn't drive. So these two would be mutually exclusive. Mutually exclusive. But they're not complementary because it's not one or the other. If he doesn't take the bus, he doesn't automatically get a speeding ticket, so we would say not complementary. Number 6, choosing an even number and choosing a number divisible by 5. So again, even numbers are sometimes divisible by 5. Let's think of even numbers. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So sometimes they are divisible by 5. So we would say that these are not independent of each other, they are dependent, because you could have both. Joe is flipping a coin 10 times and he gets heads each time. So that's very lucky to get a streak of 10 in a row, but each event is still independent of the one before it. So each time you flip a coin, that's independent. Okay. Alex is a waiter at Olive Garden and he is a chef at Olive Garden. So those two things can't happen at the same time. He could have both of those jobs, but just not at the same minute. So we would say that they're mutually exclusive. But they're not complementary because there are other jobs he could have there too. He could be a dishwasher, for example. Herman wants to pick out a pair of black socks from his drawer containing 5 black pairs, 4 red pairs, and 2 blue pairs. He picks out a red pair, throws them back in the drawer, and picks out a red pair. So this is different from my sock example because he puts them back. If he puts them back, the chances for the first choice are the same as the chances for the second choice. So those are now independent. And that's because he put the socks back. Alright, and then the last one. Rolling a 4 on a single 6-sided die and rolling a 1 on the second roll of the die. So if you roll a 4 the first time, that really doesn't change your chances of rolling a 1 on the second time. So those two events are independent of each other. So I'm going to stop this video and we'll make a new video for the dice